Welcome to InventorCAM Professor on our series of Getting Started. I'm Sydney, your InventorCAM Professor, and in this session we'll be doing our second sample of MillTurn. If we take a look at this part, this is another perfect example of how MillTurn can be used. There are parts that have to be turned on the diameter of this part itself, and besides that you have all this milling that has to be done, not only in around the part, but also in the fifth axis on this part itself. If we take again a look at our home positions, you'll see that we have our second home position, first one as shown here, third one, fourth one. Basically for every single face that has to be milled out, we have a position around the part itself, including, of course, our turning position as shown here. The first operation that I started off with was a turning operation to turn around this area over here. If we take a look at the operation itself, you'll note that my geometry is actually this area over here, and only this area. My tool was an external tool for turning, external rough. If I go into my technology area, you'll see that I've used a rough cut with a constant step down of every millimeter, plus I've also done a finish turn on the part itself. If we take a look at the simulation, and I'll use the solid verify simulation to show this part, you'll see that the tool, do it one step at a time, just simply goes down and turns out that entire area over here. Now, in my next operation, I've decided to go into my milling operations, and I decided to first start off with these four flat areas over here, going around the part itself. So I've simply done a milling operation, and I've used Mach 1 position 4, and my geometry in this particular case was just this line as you see here. Now I used a tool that was 16 millimeters. My levels, my profile depth was up until that surface itself, and in my technology area I've chosen to use left, but I've also done offset and finish, and I've also used the option of clear offset so that I can actually clean from a distance out, moving back in. Now, if I take a look at my simulation now, and again I'll use the option of solid verify, you'll note that's cleaning not only on one side, but it's cleaning on all four sides, even though I've only chosen one side to do. The reason for this, as I've previously explained in one of my previous demonstrations, is that I've used in this particular operation the option of transform fourth axis, where I've chosen the angles that I want to have this machined on as well, to turn to those particular angles, and include also the original angle that I need to work on. Now, in my next operation, I've decided to choose to work on this floor over here, and I basically use the same technology that I used for this area, except this time when I turned the part around, I only did it on two sides, for this side over here and for this side as well, but basically using the exact same technologies that I used for the previous operation. In my next operation, I've decided to work on this floor over here. So over here, I've chosen Mach 1 position 5 to be able to work on this floor as you see over here. And what I've done here is very simple. My geometry in this particular case was this line over here, this edge over there. My tool being the 16 millimeter end mill. In my technology area, Again, I've used the option of clear offset so I can work further out, doing also an offset on the wall and then doing a finish cut. If I were to show you my simulation, you'll see that the tool simply works across that area over there. In the next operation, I've chosen to work on this side now, and I've done the exact same technology that I did on the previous side to work on this side as well. Afterwards, I've decided, you know what, we have to work right now around this area over here. So for this, I've chosen Mach 1 position 4 that allow me to work around this area itself over here. The geometry in this particular case, if I would show it to you now, is this around the part itself, just that edge, using a 16mm end mill. With the technology, I've been using a rough and a finish, and over here I do not need a clear offset, and I used a link of a feed with lead in of 2mm arc, and the same for my lead out. If I were to simulate this now using the option of solid verify for my simulation, and I'll turn it to the side, you'll see that the tool simply goes down and mills out that entire wall as shown over here. Now, in my next operation, I've decided to mill out this pocket, so I'll be using Mach 1 position 5, where this is actually now the home position that I'll be working on. And if I choose my view, you'll see that this is the flat area which is facing me. The operation itself, simply chosen the option of Mach 1 position 5 with my geometry, this area as shown over here. The tool being the appropriate tool of a 6mm end mill. My levels as shown here. My upper level and my pocket depth. And I've chosen to use simple contour option in my pocket with the link of a linear ramping into the part and lead out with an arc. If I were to simulate what I've done here, you'll see again in my solid verification simulation that the tool is going down and simply milling out this pocket as shown over here. Now, as for milling goes, I still have to do this side over here and this side over here. So I've chosen to use Mach 1 position 7, where this is now my geometry. This is actually the z-axis is perpendicular to this face now. And my geometry using a profile option for machining will be this line over here. Again, my tool being my 16mm end mill. And if I go into my technology, I've chosen again to use my clear offset option to clean off that entire face. I've done it for this side, and I've also done it for this side as well. What's left now on my part is the drilling operations that have to be done, such as on this wall, this face over here, these over here, and this hole over here. And that's exactly what I've done here. I have a drilling operation for this hole over here, as shown over here. I have also for these two holes, as shown over here. For this hole, these two holes, and for these two holes. And with all these operations, we've basically finished working on a part using MillTurn. If I do now the simulation on the entire part itself, and I'll use again the option of solid verify to show the simulation, we'll see that the tool is being turned, milled on all the sides including this radius over here, the pocket, those edges, my drill points. Everything has been done to complete this part, and all this was done using MillTurn. Thank you for joining us, an InventorCAM professor. Take care and have a nice day.